Okay, so if we're looking at two different patients' vital signs, we need to consider their age and probably a lot of other factors. And so the way that we can compare these two individuals is by calculating something called a z-score. A z-score basically translates any number you want into this z-score land, which is a land where everything is on the same playing field. You know how we've always said you can't compare apples and oranges? Well, you convert an apple to a z-score and an orange to a z-score. Now they're talking about the same thing. Okay, so that's what z-scores can help us do. So to do that, you take the number you're trying to convert, so call it x, subtract by the Greek letter mu, just like a funny looking m, and then divide by the Greek letter sigma. Okay, I'm not sure why we started using Greek letters at what point, but I mean, a lot of mathematics probably came from ancient Greece, whatever. Anyway, this is the mean of the group, and this is the standard deviation of the group. And in case this is your first time hearing about standard deviation just measures how much spread is in your data set. So how much spread do we typically see from one person to the other of blood pressure in this case? So you want to convert both these people to z-scores so you can compare them for this problem. Okay, so people 60 to 64 have a mean blood pressure of 134, so that's the population mean, that's the mean of everybody, and a standard deviation of 5. We'll put that down for standard deviation. And then we have a patient that's 63, so they're within this category, and they got a blood pressure of 113, so that's the number we want to convert to a z-score. Hit enter first, then divide 5, so we got negative 4.2. That's a pretty extraordinary z-score. And then the other person we want to convert, they're 83 years old, so they fit in this group. Their blood pressure is 162. So the population mean blood pressure for people of this age is 149, and the standard deviation is 4. So obviously, if you look at this patient has a much higher blood pressure than this patient does. Let's see, this one's pretty clear cut. I'll finish it out, but you don't really need a z-score for this one. So subtract those two, divide by 4. This person's z-score, oh, I guess you do, because it's saying which one's more extraordinary. Yeah, okay, so this is why it's still relevant for calculating. If you were to just look at this, which patient has the better blood pressure, you can probably stop, I don't know, maybe we can't because I don't have enough health science knowledge. The first patient was well below the mean. The mean was 134 for their age. They had 113. But maybe that's too low because this is a pretty significant z-score. A z-score of 0 is average. So this person's got a blood pressure well below average. So maybe to a doctor that's worth investigating because that's so far below the average for their age. And then same thing for this one, except this one's in the other direction. This z equals 0 is average. So 3.25 is relatively high. They're quite a bit above the typical blood pressure for their age. Which patient had the more extraordinary blood pressure? This patient did, the first one, because their z-score is further from 0.